for your industrial IoT solution, where other platforms generally range between $1 to $5 per connected device. When built on Flex 83 middleware, you get it at $0.1 with 99% SLA. Watch how we stream data from 1 million devices and take you through the multi-stage journey with a reference application built on Flex middleware and showcase the resource observability and cloud cost involved in a real-world scenario. Let's take a closer look at how Flex 83 powers your IoT solution. A foundation layer ensures your solution is secure, scalable, reliable, and managed with intelligent orchestration. A powerful layer of 30-plus pre-built microservices built for any industrial use case. It enables 80% solution completion from the start, reducing time to market, costs, and risks. This is your platform, calling and scaling services through middleware, without ever writing complex glue code. Real-time telemetry from millions of devices streams into your platform, stress testing every layer below. Now that you've seen the architecture, let's move to the first stage, load streaming. This scenario showcased data stream for 1 million assets, sending 100,000 messages per minute. However, production applications deployed through Flex 83 are running with 50 million plus devices exercised at 100,000 messages per minute, when nominal to 1 million messages per minute under load. This is further validated for 10x load scaling with 1 million messages per second. Each load stream is configurable with data intervals, device count, and attribute profiles. For this run, data is generated every 15 minutes for 1 million devices split across multiple simulations. Device attributes like load factor or fuel rate are randomized or calculated dynamically, simulating real-world behavior. Devices are created on Azure IoT Hub, and telemetry data is streamed directly to Event Hub. Downstream applications can consume this data seamlessly, in real time, at scale, and ready to validate your IIoT solution performance. Now let's move to stage 2, your reference application in action, with data streaming in from 1 million devices. Flex 83's multi-asset handler offers both admin and customer portals. Admins configure data profiles based on asset telemetry received from the Edge simulator. Each profile defines specific parameters mapped to data streaming from IoT Hub or MQTT. Customers are onboarded through a centralized portal. Bulk onboarding is supported via CSV uploads, mapping each asset back to its source profile. Once onboarded, users get a real-time snapshot of devices, status, alarms, service requests, and asset health, displayed on the dashboard in a geographic view. Each asset's nameplate view shows its identity, status, telemetry trends, and real-time parameters, like how load factor correlates with fuel level and consumption rate. The forecasting feature allows you to forecast attribute value based on the original data. Here we can have a comparison between original asset attributes and forecasted values. Predictive maintenance models, even for select devices, highlight upcoming anomalies, like coolant temperature or system efficiency predictions. Rules can be deeply nested with multiple attributes. Creating a rule starts with selecting the profile we've created earlier. Based on the profile, we see the attributes sourced from IoT Hub or MQTT. Alarms, service requests, and policy-based rule actions ensure every triggered threshold results in an automated system response. Dashboards offer predefined widgets, or users can build custom views, showcasing charts, KPIs, and queries with zero code. Control commands like reset and reboot can be executed per asset, with audit logs tracking every change in action. Coming to the health and monitoring configurations. Based on alarms, we can define the state of a particular asset. For example, healthy, unhealthy, or chronic, based on occurrence type. With Chat AI, users can query live system data using natural language, adding a layer of accessible intelligence on top of massive asset data streams. For example, you may try asking, generate line chart for a particular asset for 6 hours duration in HTML. Flex 83's runtime intelligence gives you a live view of everything: compute usage, memory load, and infrastructure performance. The observability dashboard gives a live view of platform, application, and infrastructure metrics, each broken down across Flex 83 services. System-level compute usage like CPU, memory, and pod distribution is monitored in real time, helping teams track resource utilization under simulated load. While the default view shows usage and percentages, back-end metrics can be exposed to track total allocated compute, memory, and consumption across services. Granular breakdown of CPU and RAM usage by platform components, workloads, and third-party services helps isolate bottlenecks and optimize deployments. These insights directly inform cloud cost control, ensuring that even at high-scale load, operational efficiency is maintained. With this, the same infrastructure can support up to 1 million devices without increasing runtime cost. Let's wrap it up by looking at the final piece of the puzzle. What's the cost to run your solution at this scale on the cloud? A southbound interface that allows device management with cloud diversity across AWS, Azure, Google Cloud, or natively running at MQTT and asset connectivity flow. Taking a scenario for operational costs with Azure IoT Hub as device cloud, also keeping other factors such as number of features, data storage, and security in mind. Flex 83 gets you scale-ready and cost-efficient IoT solutions, resulting in 90% cost reduction with $0.1 per month for each connected device at 99.99% SLA. We just ran 1 million assets and over 36 features under live load to depict the cost-efficient IoT solution scalability on Flex 83 middleware. If you're stuck on scaling, let us validate your solution and build a POC on your dataset as the proof of value. Talk to an IoT expert today.